Hi everyone. Okay, today I show you how the mathematical basis to do calculations with a mechanical calculator. Okay, let's suppose I want to do this operation, this simple sum. So I would do 4 and 6 is 10, 0, 3 and 7 is 10 plus 1, 2 and 2 is 4 plus 1 is 5, 1 and 3 is 4. That would be the result. So what I do, I align correctly each digit. 4 and 6 are the units, then the next digit 3 and 7, 2 and 2, 1 and 3. So what I do here is exactly the same. I insert the first number, 1, 2, 3, 4, and then I insert the second number, 3, 2, 7, 6. Being careful that they are correctly aligned with the other number. And here I have the result, 4,510, which is what I have obtained by turning the crank clockwise. Now, if I want to do a subtraction, what I do is 2 minus 1 is 1, 7 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. And this is my subtraction done by hand. Here I do exactly the same. I insert the first number, so 4, 3, 7, 2. I insert once with turning clockwise, not anti-clockwise, because it has appeared as a positive number here. And then I insert the other number, 3, 2, 6, 1, and I turn anti-clockwise. And so I have 1, 1, 1, 1, which is exactly what I have obtained. Now, to do multiplication, the concept is simply that the reasoning is, if I wanted to do 15 times 3, I can actually do 15 plus 15 plus 15 3 times. So what I do by hand is 2 minus 7 is 14, 11, 9. And then I do this little thing here, right? And that's exactly what we do here. Instead of multiplying, we sum 3 times. So 4, 5, 7. I have to sum it 2 times, sorry. So I turn twice, 1, 2. And what I have here is 914, which is exactly what I got there in my subtotal. Now, what I do, I multiply the whole number by 3. So 15, 17, 4 times 4 is 12, plus 13. And then I do the final sum. 4, 1 is 2, and 7 is 16, 1, 1 and 3 is 4, 1. So 14,624. What I do with my calculator is I move the carriage one position. So now the numbers are aligned one position to the left. The digits are aligned that way. And I sum it another time, 3 times this time, because I have to do 557 by 32. 1, 2, 3. And I obtain 14,624, which is exactly what I have obtained there. Okay, to do division, the concept is a little bit different, but it's still the same. The idea is that if I want to do division only having multiplication at my, subtraction at my disposal, what I do, I insert my number. Let's say I want to do 30 divided by 5. I insert my number 30. I reset the counter. The counter is a register which just counts how many times I turn the crank. So, I insert 30. I insert 5. And I start to subtract it until I get to 0. And the counter will tell me how many times I have subtracted this number. So 25, 20, 15, 10, 5, 0. I got to 0. How many times I had to subtract 5? 6 times. I don't know if you can see it because it's quite dark and it's written in red anyway. Here appears the number 6. So this is the principle. Now, let's say I want to do something a little bit more complicated, like 108 divided by 6. So I would say, how many times does 6 fit in 1? It doesn't. So I have to take 10. So the 6 in 10 is 1 times. 1 times 6 is 6. 10 minus 6 is 4. And I take down the 8. And then I say, how many times does 6 fit in 48? That is 8 times. 8 times 6 is 48. Subtraction is 0. And here, what I do is the same. So I have to do it on this side, and I will see the reason later on. I insert 108 once. I reset the counter. Here I have 108. And then under the 0 of the 10, or the first 2 digits, I subtract 6 until I go underflow, which means I go below 0. The machine will tell me that. One time. Ping, you heard ping, that means I underflowed. So I sum it again because I don't want to underflow. And what I have here now is 48, which is exactly what I had here, 48. So now I move the carriage one position to the left, and again I subtract until I get to 0. Okay, I got to 0. And the counter has kept on counting how many times I had to turn, and that is 18. So 108 divided by 6 makes 18. And here we had division. Let's go to the square root. So the square root comes from this thing that humans found out, that 1 is equal to 1 squared. 1 plus 3 is 4, which is equal to 2 squared. 1 plus 3 plus 5 is equal to 9, which is 3 squared. 1 plus 3 plus 5 plus 7 is equal to 16, which is equal to 4 squared. So the idea is that if I have my number I wanted to do square root, if I subtract each odd number one after the other, when I get to 0 and I count how many digits I had to subtract, I will get my square root. Here we have 1 subtraction, 2, 3, 4 subtractions. So the square root of 16 is 4. Okay, we do it here with a little bit of a more complicated number, but not too much. Let's do 36. So I insert 36. It appears here. Sorry about this number, but it doesn't bother us. Anyway, I can redo it. 36. Okay. Reset the counter. And now I start here subtracting 1. 36 minus 1 is 35. Then I subtract 3. Then I subtract 5. We are now 27. I subtract 7. We are 20. I subtract 9. We are 11. Now, the next odd number is 11 after 9. I subtract 11, and my result is 6. So the square root of 36 is 6, as we very well know. Now, of course, I can do more complicated square roots. I don't know how many of you know about the algorithm to do square roots. Anyway, it works like this. If I want to do the square root of 961, I have to count from the left, from the right, and divide the number in groups of 2. So in this case, I only have 1 dot to put. Then I look for the smallest perfect square, which is equal or a little bit underneath the number 9. So in this case, it's 9, because 9 is 3 squared. So I write 3 here. I make 3 squared is 9. 9 minus 9 is 0. Now I get the 61 down, and I divide it. Here I put a dot, and I divide it by the double of my result. So I say, how many times does 6 fit in 6? That is 1 time. I write 1 here, and I write 1 here. I do 1 times 1 is 1. 1 times 6 is 6. 61 minus 61 is 0. So the square root of 961 is 31. Here we actually do a very similar thing. We start inserting the number. Let's do it here. Oh, here it's okay. 961. I insert the number. I reset the counter. Now, since there we had to look for the square root of 9, basically, here we start subtracting the odd numbers under the number 9. So I subtract 1, I subtract 3, I subtract 5. It hasn't sounded yet, so I subtract 7. Oh, too much, so I go to 1. I put the 6 on, and I move next. I move to the left. And now I start again on the next. line. So I subtract 1. Okay, I got to 0. My square root is 31. And you see here we have 61, which is exactly the number that we had here. Of course, to get this to be understood, I may be doing later another video where I explain more in details why this whole procedure works, but we are not really used to do by hand any square root anymore, so I would have to use some algebra to explain exactly if that is of interest for someone. Anyway, the whole point I wanted to make is that we can do square roots with mechanical calculators, even complicated square roots. I have some students who are capable now of doing 8-digit square roots, which gives a result of 4 digits in less than a minute. They can do it with a mechanical calculator. So if you think about the past, when there were no computers, there were no electronic calculators, this was indeed a very great advantage to be able to do this kind of calculations so easily, with basically a practical algorithm, which if you followed correctly, you could not do any mistake and get to the correct result. Okay, that's it for today. Thank you very much for listening. Bye. Bravissimo.